Welcome to the video. We are going to solve clone and undirected graph. In this question, we are given a graph, okay, in form of adjacency list along with its neighbors, and we have to clone this graph and return it. If we have successfully cloned it and returned it, the driver code will print 1, which is the correct one. Okay, and if we are not possible to clone it, it will return 0. Okay, so in every case, if we are doing correct, it should print 1. Cool. Now let's do it. So first of all, I will do a DFS in this question. Okay, I will create a dictionary which will check if the particular node has been already been present or created in our cloning pattern or not. If it does, return it value. If it is not already present in our dictionary, then create it along with its neighbors and return them. Okay, successively. So first of all, I will create a dictionary. I will employ a utility function in order to write a clean code, and the utility function will be util. Okay, and we'll pass the given node in this utility function. Cool. Now let's build our util function. So I'm taking node here. Okay, you can take n or whatever you want to. I'm just removed e from here and I'm employing it. Okay, now if the base condition, if not node, if the node is not there, if node is not there, it's a base condition. We have to return nothing. We have to return nothing because we do not have anything to return to. Okay, now if this particular node, if this particular node is already in dictionary, return its value. If this particular node is already in dictionary, return its value. I will repeat again. If this particular node is already created in our cloned dictionary, then return it. Okay, return its value. Okay, if it is not, if it is not, if it is not, we'll have to create a particular node of this particular given one, okay, along with its neighbors. So you can see in the driver code also you have two things. Okay, value of node and its neighbors. It is empty list from the beginning, and we will do DFS. We'll go deep down to this particular node when and we'll append its neighbors to its, okay, into this empty list. Remember that. Now now since we have to go inside its elements in its neighbors, remember one thing more, that the spelling of neighbors is mistaken. If you are very grammar nazi, you may face a problem. Okay. Okay, so node dot value dot neighbors dot append the value of neighbors to this particular node, which will be using this recursive function. And is what, and is this neighbor, particular neighbor of this node. Cool. At the end, return dictionary node dot value in a dictionary format. Okay, let me submit and check our approach. Okay, yeah, it is able to. Okay, now, so this is recursion problem. Since we are doing in Python, it is taking more time and it is exceeding the limit of recursion. I will employ this method, set recursion limit, and I will exceed the depth of this maximum recursion. Okay, yeah, this time it did the job in very less time. So hope you enjoyed it and learned a new concept. Thank you. Have a nice day.